Assalamu alaikum. Bismillahirrahmanirrahim. We have discussed in the previous class 180-degree voltage source inverter, and here we are going to discuss three-phase voltage source inverter with 120-degree mode. The difference between 180-degree and 120-degree, as we take a view of the previous class, if we say this is a 180-degree. The difference is only is that the conduction, if T1 is conducting, it is conducted for 180 degree. So this is the sequence. You know that T1, T1, T1. It is pairing with each of the thyristor for 60 degree, and total it is conducting 180 degree. This is 180 degree. This is 180 degree. Now then this is. Everything is the same. This is 180 degree. Now let's come back to our topic. Now we will discuss three-phase source inverter with 120 degree mode. Similarly, the three-phase, we have a three-phase star connection. T1, T2, T3, T4, T5, T6. We have a 6 IGBTs or thyristors, whatever it is. These capacitors are there to maintain the voltage across these IGBTs, and these diodes are used for the protection of these IGBTs, because when this IGBT is not conducting, high voltage will appear across this IGBT and it can damage the IGBT easily. Okay, let's start. Now each of the thyristor will conduct for 120 degree as the mode suggests. Let's discuss one by one. If Q1 is conducting, it will be pairing with Q6, Q2. Okay. Q6, Q1, Q1, Q2. Again in the next cycle Q2, Q3 and Q4, Q3. This is a very simple explanation of very basic diagram to illustrate this phenomenon. Q4, Q5 or Q4, Q3. This is over here Q5, Q6 and Q5, Q4. This one is over here Q5, Q6, Q6, Q1, Q1, Q2 and Q1, Q6, Q2, Q1. You already know that it is paired with the previous one and the next one. Okay. Let's see step 1. Look at the diagram. When it is pairing with Q1 and Q6, Q1 and Q6. Look at the diagram. What is your circuit? It is just a series connection. R neutral point, and we have Y point here. You understand? One neutral point, and this is other switches are just open. And what will happen? Voltages are just the source voltage is divided half by half, because this impedance is equal. Vs by 2, Vs by 2, and you have a output voltage like that. Across these, let's derive the phase voltages and the line voltage. From R to N, this is Vs by 2. From Y to N, minus Vs by 2, this minus is to the reference point. And VBN, since there is no connection, these two switches are open, there is no voltage across this space. We have included the phase voltages. Let's go for the line voltages. VRY. What is this? This one is VS. You have to sum up VRY. Keep moving. Then VYB. Just VYB. And if you look at the diagram, VYB is minus VS by 2. Need to be VYB from this point to this point. Actually, this is just a nothing. This point is over here. Can you understand how this is? This B point is over here, and actually this is the neutral point in this case, because there is no conduction path over here. And if you use a multimeter, the voltage across this point, it will be Vs by 2. You need to be careful about this point. This is very tricky. And how would BDR? If you are going to measure from B to R, you have to measure from B to R. So neutral point to the other point, and you will get this is the positive, and this neutral point is negative. So we have concluded for step 1 the phase voltages and the line voltages. Take a review. Phase voltages are pretty simple. You need to just add them up. Take that sequence Q1, Q6, Q1, Q6. Take that impedances, add them up, divide the voltage, write down like that. Be careful about the sign. For the line voltages, you need to be careful. B point is at the neutral, okay, because there is no connection over here, and if it is here or here, there is no difference. Ry is simple Vs, Yb is minus Vs by 2, and Vr is Vs2 by 2. For the step 2, let's see what is the circuit diagram. It is converting Q1 and Q2. Q1 and Q2. What will happen now? If you look at carefully, yes, sequence is like that. It is conducting now through V. Write down the V Rn is equal. We already know that the equal impedances share the equal voltages. The Rn, we already know that. By 2 Vbn, which is okay, Yn. There is no voltage, it's a short point. There is no conduction point from here to here. Open circuit, and Vbn is minus Vs by 2. Okay. I think you are following my point. You need to be very attentive, otherwise you will lose the plot. Okay, these are the phase voltages. Let's go for the line voltages. VRY from here, VRY. R is open. No, we know that. What is this? Vs by 2 around this leg. Ry, Y is somewhere over here. It's connected to the neutral, and this is the same as this Rn. What next? Yb. Yb, it is also the same as Yb. Really true. It's an interesting phenomenon because Y is at a positive potential with respect to the B, and the last point is Br. As I already told you, we are taking the clockwise sequence for the line voltages RY, YB and ER. This is the situation. Okay, I hope you have understood it very well. Okay, we have just concluded two steps. Okay, step 1, we have seen the phase voltages and put those in the table. Okay, Vs by 2 minus Vs by 2 is 0. Similarly, you go back and see for the step 1, and this is our step 1. Rn and Yn has a value Bn is 0. Okay, and Yn is negative. Okay, Bn is 0, Vs by 2, Yn is negative. Similarly, the case for the next one, which is Rn Vs by 2, Yn is 0, and N is minus Vs by 2. So does this one. Okay, you can repeat the same process for the next. Okay, you can see that this diagonal is 0. This diagonal is 0. Okay, and but to fill up this table, you need to work with each combination. Be careful. Be careful. You need to be work with all the combinations. You cannot just write down these two, and it's very hard to also remember these things. Similarly is the line voltages, which we have already seen over here. Suppose we take the step 2, this is Vs by 2, Vs by 2 and minus Vs. Okay, minus Vs, Vs by 2. So we are taking the step 2. Okay, step 1, we have some other scenario. Okay, this is our step 1. Vs, Ry is Vs minus Vs by 2 minus Vs by 2. Okay, this one. Vs minus Vs by 2 minus Vs. Similarly, you need to go through the exercise of all the combination and compute the line voltage and phase voltage as you have done in your previous case. Okay, let's keep moving one by one. You can also find some kind of similarities between these two. It's a diagonal is like this, 0. Here you can see that in the diagonal there is some values with the signs are different. Look at this diagonal, look at this diagonal, look at this diagonal. This is the check. You can check your values by looking at these diagonals. Diagonally you have the same. Look at this diagonal, you have the same value, just with different signs. This is for your corrective measure. Okay, and you just check whether you have done it right and wrong. Same value in the diagonal with different signs. Okay, signs can only be verified from the circuit. Similarly, okay, let's plot this one. Okay, these are the phase voltages, and at one time, you know that two are conducting, and we can see that Q1 is conducting. Oh, sorry, Q1 is conducting. We have Rn and Yn, and there is no Vn. Okay, we already seen this. Similarly, this is again Q1 is conducting with combination to Q2, and at that point it is Yn is 0 and we have a V. Keep moving, and then we have a combination of Q2 with Q3, which is over here. Rn is 0, Actually, these values are taken from this table. Okay, okay, you see Pn is 0. Pn is 0. Okay, this is plotted from the start of the table. Okay, Yn is 0. This is Yn is 0, and rest is the Vs by 2 minus Vs by 2. Then Rn is 0. That Rn is 0, and Vs by 2 minus Vs by 2. Vs by 2 minus Vs by 2. We go for the next step. Okay, sorry, I have overstepped. Minus Vs by 2, minus Vs by 2, and Vn is 0. Vn is 0, Vs by 2, and minus. In this way, you can construct a phasor voltages. Okay. So does the next point. You have a situation for the line voltages. You can see the table. Let's go back and see the table. Here we can remember two values. Ry is Vs, and X is minus Vs by 2. Just for your clarity and for your understanding, the rho always sum up to 0. 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 Vs minus Vs. Vs by 2 and Vs by 2. Vs by 2, Vs by 2, and minus Vs. Minus Vs by 2, and this is 2Vs, this is Vs, and this is minus Vs by 2. It sums up to 0, and similarly this is Vs plus Vs plus Vs. This is minus Vs. This is Vs by 2, which then sums up to 0. So does the case for the next step, and in this way you can construct the line voltages and phase voltage for 120-degree conduction mode. Okay, let's take a review. It's a pretty simple as compared to 180-degree, where three are conducting at one time. You need to remember this configuration forever. Okay, this configuration is extremely important. Which one is conducting and which one is not. Okay, you can take any one, but you need to be quite simple. Step 1, Q1, Q2, Q6. Okay, Q6, Q1, Q1, Q2, Q2, Q3. Okay, you can easily compute the voltages. You need to take a look, stream rating flow. Okay, this is the scenario. This is the next one. There's voltage and line voltage are computed from the circuit. The important thing is that which one is not conducting. That point will be moved over here, and with that reference we need to do that. And for the next step, we have identified the potential. And we can compute the phase voltages and the line voltages. These are the phase voltages and line voltages. Okay. So this is the table. You can construct this table from the previous lot by drawing each the, and the trick is everyone sums up to 0. Sums up to 0, this also sums up to 0. Okay. And then just this is the graphical representation of this table. This is the line voltages, which are pretty important in this case. Now we have concluded our topic, and it's extremely interesting to view. In the case of 180 degree, 3 thyristors are conducting. In the case of 120 degree, 2 thyristors are conducting at one time. And you need to just look at the equivalent circuit at that time, and you can just take a look. I think you are now comfortable with this 3-phase inverters. You need to be very precise in. I also provide you the tips to easily memorize these circuits. These circuits are very important. In the exam, you are asked to just draw these and like that. Okay, thank you very much for your attention.